name is integers. So let's start this chapter. The first subtopic in this chapter will be negative number and integers. So that means we will learn what are negative number and what are integers. So let's start the lesson. What are negative numbers? Negatives are the natural numbers. I know that you know what are natural numbers. If you don't know what are natural numbers, the link for that is in the description. Negative or natural numbers are useful to denote situations that are opposite in directions, or like on signs, like east or west. The opposite situations are denoted by plus and minus. The numbers which have the addition sign are known as positive numbers, and they are like +1, +2, +3, +4 and so on. But we actually don't write the plus sign for +1, +2, +3 and +4 because we already know that they are all positive. The numbers with the minus sign are known as negative numbers, which are -1, -2, -3 and -4 and so on. We write minus sign in this because if we don't write the minus sign, we will not be able to differentiate between positive numbers and negative numbers. And then we will only be able to differentiate these positive and negative numbers on the number line, as the positive numbers on the number line is always on the right and the negative numbers are always on the left. And the number which is separating both positive and negative is 0. Now we will learn about some real life examples of negative numbers. Profit or loss. If a profit of 100 rupees is denoted by +100 rupees, then the loss of 100 rupees is denoted by -100 rupees. Deposit or withdrawal. For deposit of 500 rupees is represented by +500 rupees, then -500 rupees represents a withdrawal of rupees 500. Temperature. The temperature of a place 5 degrees above 0 degrees is known or written as +5 degrees Celsius. And the temperature of a place 5 degrees Celsius below 0 degrees Celsius is written as or known as -5 degrees Celsius. Now we will learn what are integers. The positive numbers 0 and negative numbers together make a new collection of numbers called integers. In other words, the collection of natural numbers, which are 1 to infinity, whole numbers which is 0 to infinity, and negative numbers form a new collection of numbers called integers. We denote these collections by the symbol Z or I. Thus, Z or I is equal to -3, -2, -1, 0, 1, 2, 3. And this is only for your information to know that 0 is neither positive nor negative. We also have a diagram explaining what is integers. So, natural numbers, as you can see, is the smallest, which contains only positive numbers. Whole numbers is a little bigger than natural numbers as it contains 0 and natural numbers. Or you can say that as positive numbers. And integers is the biggest because it contains negative numbers, whole numbers, which is 0 to infinity, natural numbers, which is 1 to infinity, and positive numbers. So, what did we learn in this session today? We learned what are negative numbers, real life examples of negative numbers, and what are integers. So if you guys like the video, please like, share, subscribe, and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. welcome back everyone. Today we're going to continue with the same chapter, integers, but we're now going to learn about a new subtopic which is about representing integers on a number line. So let's start. What is the best way to represent integers? It is the number line, or you can even call it the number range. What is a number line? Yes, you're correct. It's a line just like this. And in the middle there is 0. Towards the right, we have positive integers, which is 1, 2, 3, 4, and 5. This is the positive integer. The line is indefinite. We always get seen every day. We get new numbers. So, number line is indefinite. The distance between any two numbers in the number line is always equal. In the left side of the number line, we mark the negative numbers, which are -1, -2, -3, -4, and -5. All are in equal intervals. Since the negative numbers and the positive numbers go on forever, we mark numbers at the ends of the number line. This arrow tells that there are infinite positive numbers towards the right, and this arrow tells us that there are infinite negative numbers to the left. Not only that this is a good way to represent integers, but this also helps us in innumerable ways. We will discuss more about its uses in the next videos. So if you guys please like, share, subscribe, and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. Hello and welcome back everyone. Today we're going to continue the same chapter, integers, but we're going to continue with the same subtopic also, but this is part 2. So let's start the lesson. This is a number line. We have 0 in the middle, positive numbers to the right, and negative numbers to the left. We can say that to the right, the numbers are increasing. But we can also say that the numbers to the left are decreasing. First, let us choose any positive number. Suppose we'll choose 1. And now we have to choose any number to its right. Suppose we'll take 3. This proves that 3 is bigger than 1. We all know that. Now, suppose we'll choose 1 and another number. Suppose 4. We can also say that 4 is bigger than 1. Now, let's choose a number to the left of 1, like 0. So, this also proves that 1 is bigger than 0. Suppose now we choose minus 4, and we can say that minus 4 is also less than 1. Here's a very basic thing to remember. It's that right is always equal to larger, left is always equal to smaller. Right equals to larger, whereas left equals to smaller. And this helps us understand one very easy concept, is that any positive number is bigger than any negative number. This is because that all positive integers are to the right and are bigger than all negative integers. Now let us learn about a new concept using this same number line. Every positive integer has a corresponding negative integer. What do you mean by that? Suppose we took the number 2. The number 2 has one corresponding negative number, and that is minus 2. So this proves that minus 2 is the opposite of plus 2. This can also be the other way around, meaning that plus 2 is also the opposite of minus 2. Every negative integer also has a corresponding positive integer, which means that plus 2 is also the opposite of minus 2. Suppose we're asked to find what is 3 more than 1. What do you think we will do? Yes, we will move 3 to the right of 1. So 1, 2 and 3. That gives us 4. So we can say that 3 more than 1 is equal to 4. Why did we move to the right of 1? It is because we have to remember that the right is always increasing or greater. So now, what if we ask to find what is 3 less than 1? So, what will we do? We will select the number 1 and then we will move 3 steps to the left of 1. Like 1, 2 and 3. So, the answer we get is minus 2. That proves that 3 less than 1 is equal to minus 2. There is no end with what we can do with a number line. So, we have to make sure that we understand the number line really well, so that we don't make any mistakes when we become big. So, if you guys like the video, please like, share, subscribe and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. Hello and welcome back everyone. Today we're going to continue with the same chapter, integers. Now learn about a new subtopic, and that is absolute value. So let's start the lesson. Our first question will be, what is the absolute value of minus 3? We will write it like minus 3, but there will be one vertical bar to the left and one vertical bar to the right of minus 3. This thing here shows how to represent the absolute value of minus 3. Absolute value just tells us the distance from 0. We had a number line like this. It means that to find the absolute value of minus 3, we have to check its distance from 0. So it will be 1, 2, and 3. So that means the distance from 0 is 3 units. We have to always remember that the distance from 0 can never ever be negative. It will always be positive. We cannot say that the absolute value of minus 3 will be that minus 3 units away from 0. We can say that it is plus 3 or positive 3 units away from 0. So that is our answer to this question. The absolute value of minus 3 is equal to positive 3. Now take another question. So our question is, what is the absolute value of plus 3? What is it? Okay, so now we'll have to again check what is the distance of 3 from 0. So it'll be 1, 2, and 3. We can again say that 3 is 3 units away from 0. Absolute value will be represented with a vertical bar to the left, 3, and then another vertical bar to the right. So that brings us to our answer, which is plus 3. So now let's check out some other questions. Like, what is the absolute value of plus 6? As it is 6 units away from 0, it will be 6. Now let's check for another question. Like, what is absolute value of minus 20? As it is 20 units away from 0, we'll say it is 20. And our last question is that, what is the absolute value of minus 150? As it is 150 units away from 0, we will say that it is 150. Look at all these answers. Isn't it all positive? So, wouldn't it be right to say that the answer of absolute value will always be positive? To get our answer for this question, I will ask you another question. And that is, what is the absolute value of 0? 0 is 0 units away from 0. So the answer would be 0. But is this answer 0 positive or negative? We cannot say either of that, as 0 is neither positive nor negative. So it will be wrong to say that the answer will always be positive. But we can say that the answer will always be non-negative. And what does non-negative mean? Non-negative means that the answers will always be positive or 0. So that will be our answer. So if you guys like the video, please like, share, subscribe, and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. Welcome back everyone. Today we're going to continue with the same chapter, integers, but we're going to learn about a new subtopic, and that subtopic's name is Successor and Predecessor in integers. integers. So let's start the lesson. Predecessor and successor of an integer. Predecessor of an integer is the integer which is one step or to the left which of the given integer, or we can say it is one less than the given integer. For example, predecessor of -3 is -4. Successor of an integer is the integer which is one step to the right of the given integer, or we can say it is that one more than the given integer. For example, the successor of the integer -3 is -2. Our first example is that to find the value of a and b on the number line. Our solution will be that we can find the missing integer using the integer number present beside it. A is the successor of integer -4. Therefore, a is one more than -4, which is -3. B is the successor of integer 1. Therefore, b is one more than 1, which is 2. Example 2 is to find the value of a and b on the number line. Our solution is that we can find a missing integer using given integer number present beside it. A is the successor of integer -7. Therefore, a is one more than -7, which is -6. B is the predecessor of integer -4. Therefore, b is one less than -4, which is -5. So, what did we learn today? Today, we learned what is successor and predecessor in integers and examples of successor and predecessor. So, if you guys like the video, please like, share, subscribe, and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. Welcome back everyone. Today we're going to continue with the same chapter, integers, whereas we're going to learn about a new subtopic, and that subtopic's name is comparing and ordering of integers. So let's start the lesson. To compare integers, we have to compare the signs as well as the magnitude or the size of the numbers. The greatest numbers are graphed farther to the right. We have to remember that negative numbers are always less than positive numbers. The greater numbers are the positive numbers, and the positive numbers are always to the right, whereas the lesser numbers are always negative numbers and they are graphed farther to the left. The larger a negative number is, the smaller is its value. For example, -9 is less than -1. We have to always look at the signs of the two numbers we are comparing. If we are comparing a positive and a negative number, the positive number is always greater. If they are both positive, the larger number is greater. Whereas if they are both negative, the one with the larger number is the smaller number. Now we will learn comparing of integers. Let's compare -3 and -1. First, you have to graph each other on the number line. -3 and -1. The one farther to the left is a smaller number. So, -3 is smaller than -1. Or we can also say that -1 is greater than -3. Now we will learn how ordering of integers. We can use a number line to order a set of integers. This is our first example, in which you have to order the following integers from least to greatest using a number line. The integers are -9, 6, -3 and 0. First, you have to plot each integer on the number line. Then you have to put them in the order they appear from left to right, since smaller numbers are on the left. The answer will be -9, -3, 0 and 6. Now we will show it on the number line. if we are putting them in order from the greatest to least, we would write them in order from right to left. Larger numbers are always to the right. -9, -3, 0 and 6. We can also compare all our negative numbers, then compare all our positive numbers. For example, we have to put the following in order from greatest to least, which the integers are -4, -3, 11 and -25. First, we have to compare our negative numbers, which is -4 and -25. Then we have to compare our positive numbers, which are 3 and 11. In negative numbers, the -4 is greater than -25, and in positive numbers, 11 is greater than 3. Then we have to put them in order, which is 11, 3, -4 and -25. So, what did we learn today? Today we learned how to compare integers, comparing of integers and ordering of integers. So if you guys like the video, please like, share, subscribe and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day. Hello and welcome back everyone. Today we're going to continue with the same chapter, integers, whereas we're going to learn about a new subtopic, and that subtopic's name is signs of integers. So let's start the lesson. This is only for summarizing our concepts because we will need this concept which we learned in the last video in signs of integers. So let's start the questions. The first question is -4 dash or -2. Which is bigger and which one is smaller? So first, we will take it on the number line. As we know that numbers on the left are always smaller, numbers on the right are always greater, we get to know that -2 is greater than 4. But how will we represent it? That's where the greater than symbol comes into it. That is, it looks like a crocodile head. So that means that -2 is greater than -4. And our last question is that -3 or -6. Which one is bigger and which one is smaller? So we'll again take it into the number line. And in the number line, -3 is on the right, whereas -6 is on the left. So that means -6 is less than -3. And the less than symbol is just the opposite direction of the greater than symbol. In the previous example, we have seen in its numbers, there's even a set of numbers called the negative numbers. So these negative numbers, we use it to indicate many situations. Let's see some more illustrations. For example, Aman received 500 rupees as his pocket money. So, what do you think? Which sign will we use to denote this? Yes, as his pocket money is getting increased, it will be a plus sign. But what if this situation was completely the opposite? So that means, what if Amar spends 400 rupees from his own pocket money? Now what do you think? Will it be plus or minus? As this is decreasing from his pocket money, we will do minus. Here we can note that to change the sign of the situation that is opposite to the given situation, we change the sign to represent that situation. Now let's go for our second illustration. Now let's consider two opposite situations. Rahul and Priyanka started a new business. In their first year, they incurred a loss of 50,000 rupees. What would be the opposite of this situation? You can say that they have incurred a profit of 50,000 rupees. That's correct. Now, let us write the above two situations using these signs. A loss of 50,000 rupees can be written like this and said minus 50,000 rupees, and a profit of 50,000 rupees can be written like this and said like plus 50,000 rupees. Using all these illustrations, we can say that when a person gets pocket money, the degrees above 0 degrees Celsius, and a profit of 50,000 rupees is equal to plus sign. And for the opposite, a person spending 400 rupees out of their pocket money, a loss, and the degrees below 0 can be represented by the minus sign. Many more situations in which that can be represented by a plus sign or a minus sign. And to change the situation to opposite, we can simply just change the sign to its opposite. We see integers on the number line. We've compared them, and now we also discussed about denoting them with a sign depending on the situation. What more can we do with these integers? We will see all of that in the next lessons. So, what did we learn today? We learned comparing of integers, signs of integers, and denoting integers with a sign depending on the situation. So, if you guys like the video, please like, share, subscribe, and hit on the notification bell to get more notifications too when I upload more videos. Thank you and have a nice day. Hello and welcome back everyone. Today we're going to continue with the same chapter, integers, whereas we're going to learn a last subtopic, and that is adding and subtracting integers. So let's start the lesson. Rules of addition. Now we first have to learn the rules of addition. Then only we can add integers. So the first rule is that when the signs are the same, we have to add and keep the same sign. For example, minus 2 plus minus 4 is equal to minus 6. When the signs are different, we have to subtract and use the sign of the larger number. For example, minus 2 plus 4 is equal to 2. Or also 2 plus minus 4 is equal to minus 2. This is now karaoke time. Same signs add and keep, different signs subtract. Keep the sign of the higher number, then it will be exact. So now let us solve this question. Minus 1 plus 3. As we learned in the addition rule, whenever the signs are different, we have to subtract and keep the sign of the larger number. So when we subtract minus 1 and 3, we will get 2. And we'll put it positive 2 because a positive 3 is larger than minus 1. So the answer is 2. This is another question. Minus 6 plus minus 3. As we learned in the addition rules, when the signs are same, we'll just have to add and keep the same sign. So when we'll add minus 6 plus minus 3, we will get minus 9. So this is our answer. Now we will learn about the additive inverse. The additive inverse or opposites of two numbers add to equal 0. For example, the additive inverse of 3 is minus 3. To explain this, we learned the rules of addition that if the two signs are different, we will have to subtract them and keep this sign of the larger number. So when we subtract positive 3 and minus 3, we will get 0. And 0 is neither a positive number or non-negative number. So we will just write 0 as the answer. So that means the additive inverse of 3 is minus 3. We will use the additive inverse for subtraction problems. Now, before continuing on to subtraction, we'll have to first learn what is subtraction. What's the difference between 7 minus 3 and 7 plus minus 3? Yes, 7 minus 3 is equal to 4, whereas 7 plus minus 3 is also equal to 4. The only difference is that 7 minus 3 is a subtraction problem and 7 plus minus 3 is an addition problem. So that means that subtracting is the same as adding the opposite. To learn the subtraction rule, our first rule will be that we have to keep change. That means 7 minus 3 means we will keep 7 and then change the sign to positive, and then we'll change it to minus 3. And when we do that, we'll get 7 plus minus 3. And then we will get 4 as our answer. Now, let us learn about the rules of subtraction. When subtracting, we have to change the subtraction to adding the opposite, which is keep change, and then we have to follow our addition rules. For example, minus 4 minus 7. It'll become minus 4 plus 7. So different signs is equal to subtract and use a larger sign. So our answer will be positive 3. As minus 4, when we subtract minus 4 and 7, we will get 3. And as 7, positive 7 is larger, we will put it as positive 3 is the answer. For a second example, minus 3 minus positive 7. So it will be converted into minus 3 plus minus 7. This for same signs we'll have to add and keep the sign. So our answer will be minus 10. Now these are some more questions based on subtraction of integers. So now let us solve this question. Which is equivalent to minus 12 minus minus 3? So when we will use the keep change method, we will get minus 12 plus 3. So this is our answer. So the answer is the second option, minus 12 plus 3. This is our second question. 7 minus minus 2 equals to what? We'll use the keep change method. We'll get 7 plus 2. And as per the addition rules, whenever the signs are same, we'll have to add both of them and keep the same sign. So it will be 7 plus 2 is equal to 9. And both are positive, so the answer will be positive 9. So that means the fourth option is the correct answer. So what did we learn today? We learned how to add integers, rules of addition, additive inverse, what is subtraction, and rules of subtraction. So if you guys like the video, please like, share, subscribe, and hit on the notification bell to get more notifications when I upload more videos. Thank you and have a nice day.